So, hi everyone. So as Chris said, very recently, Core Power, ABS, and Athlos Energy have initiated a project to uh, investigate the feasibility of deploying floating nuclear power plants in Greece. And this brings this panel together today. So I am joined by Arla Pamlari, our senior analyst at Core Power, Aspasia Petris from the Greek Atomic Energy Commission, Chris Lodopoulos from ABS, Dionysios Chionis from Athlos, and we also have a special guest, last moment guest. This is how things happen in Greece, so this is no problem. Aphrodite Xidi from Dion Policy Institute. So I'd like to ask the panelists to introduce themselves, starting from Arla, and provide a short opening statement for your organization and what you do.
Hello, everyone. My name is Arda Bamlari, and I am a technology analyst at Core Power. Essentially, I will introduce to you and deliver a little bit on the feasibility study that we have worked in collaboration with Athlos Energy and the ABS regarding the feasibility of potentially deploying floating nuclear power plants in selected sites in the Mediterranean and particularly in Greece. Hello, everyone. I am Aspasia Petris. I am a regulatory officer and electrical engineer by training, currently working at regulatory adaptation at the Greek Atomic Energy Commission. It's an honor to be part of this distinguished panel to talk about regulatory adaptation in this evolving nuclear maritime ecosystem. Traditionally, regulators and regulatory systems were considered entry barrier to innovation. However, the current regulatory concept embraces agility and cooperation with the industry to balance the contrasting needs of safety and innovation. The Greek Atomic Energy Commission is the national competent authority on nuclear safety and radiation protection. It licenses, inspects, and regulates the safe use of nuclear technology and ionizing radiation in the country. And recently, it has been reorganized to separate its technical functions from its regulatory function to enhance its independence and effectiveness. And today, we will talk about the current national regulatory and legislation framework regarding nuclear safety in Greece and the challenges that the technologies we're talking about today are posing to our regulatory system. Thank you.
Hello, my name is Chris Leontopoulos. I'm the Vice President of Technology in ABS based in Athens. I've been 18 years with ABS. Our technology department is a supporting facility. We support the classification main business streams of surveys and plan approval. Technology effectively is synonymous to research and development. So we're doing research and development projects, joint development projects and government projects on alternative fuel technologies and many other new technologies that eventually will find their ways into the rules and regulations, guides and guidance notes. That's about me. Thank you.
Hello to everyone. My name is Dionysios Chionis. I'm a mechanical and nuclear engineer with a PhD in nuclear reactor physics in Switzerland. For the last 8 years, I work in the Swiss nuclear industry, and I am the head of nuclear reactor physics for 3 nuclear power plants in Switzerland. However, I'm not with this hat here today. Last year, together with my partner Stathis Vlasopoulos, we formed Athlos Energy, which is the first Greek company in the nuclear industry. And we have practically 2 goals. The first one is to engage the stakeholders in Greece in order to promote the nuclear applications. But at the same time, we have a very ambitious commercial project and goal. We want to prepare and construct the first nuclear power plant in Greece. So I think that's a bold statement, and you will have some questions today, and I'm here to answer them.
Firstly, thank you for letting me join last minute. I will try to be brief. My name is Aphrodite Xidi, and I am the co-founder and executive director of Dion Policy Institute. It's the first think tank of the Hellenic diaspora. We're based out of Boston, and the concept is that there is a lot of Greek expertise abroad, a lot of people in this room, and we try to tap into that expertise to make policy recommendations for Greece. One of our focus sectors is energy and climate. My co-founder happens to be a nuclear physicist. So along the same lines of what Dionysius is doing and thinking, we think that there's an opportunity for the country to bring nuclear energy to Greece. And one of the things that we did, along with Yannis actually, and Chris's colleague Spiros Girdaris, is that we published a study about one, nuclear energy in shipping, so nuclear propulsion, and two, floating nuclear power plants. And this was published by Nafteboriki a few months ago, as in what we call in Greek entheto. And I think it had, it was, I think, the first big piece to be published about this topic in Greece. And we're trying to push forward the conversation and help streamline a few of the challenges that are starting to appear in terms of bringing nuclear energy to Greece.
Perfect. So I will ask them a couple of questions and then we'll open into the floor for the general discussion. So starting with Chris, of course, we heard from Chris Wernicke that ABS was the first class society to publish rules for floating power plants. Could you tell us from your perspective a bit more about ABS strategy in this space and also other projects you might look at?
Thank you, Giannis, for the question. I think I've been actually covered by Chris and everybody else before. It was a very, very interesting set of lectures and lots of information, very interesting in depth. So ABS is taking a proactive stance on nuclear, and that's quite clear. And this is justified also by the fact that last week we had this agreement between the United Kingdom and United and US on the technology prosperity deal, parts of which had quite extensive references to nuclear power propulsion. And it is quite interesting that both nations commit to these applications for civil nuclear power. And it is quite encouraging to see that there's going to be potentially a corridor, so-called green corridor, nuclear corridor, between these two nations. And therefore, what I wanted to say is ABS, as also mentioned by the previous, has been a pioneer in nuclear regulations. We were the first class society to publish nuclear regulation in the 1960s. We are the first class society to class NS Savannah, that was mentioned quite a few times earlier. And of course, that goes back to 1960s, but today, 2025, we are bridging the gap between the then regulations and today's regulations. So very, very recently, we published the FNPP guide, the Floating Nuclear Power Plant Guide, and we have rules for propulsion of nuclear power plants in ships, and therefore we are, as I said, we're bridging this gap, and we are now not looking at sort of old-fashioned, obsolete IMO rules of the 60s, but modern, contemporary regulations which are in accordance with the standards of the International Energy Authority, the IEA. Which is quite a lot of work to be done at this stage. Now, again, ABS, as far as technology is concerned, we are working with we do these joint development projects. So we do partnerships with technology institutions, owners, operators, shipyards, and we have specific deliverables. And in the nuclear power, we also have, I think, 17 ongoing projects worldwide at the moment. Some of them have been, some others have been completed. Some others are being planned. Just to mention, companies involved in these: Bahri, Siemens, NTT, Hyundai, Samsung, Wilson, Moldec. It's a lot of companies around the world that are involved in either FNPP type of projects or nuclear power plant projects. In our case, Core Power, I've not mentioned Core Power, of course, in Athlos. We have this newly commenced project about the deployment of FNPPs in the Eastern Mediterranean and in Greece. And we are very excited about that. We're going to do this PESTLE analysis, which is a political, environmental, social, technological, and economic and legal factors study. The result of this study is going to be a white paper, which is going to be publicly available for the purposes of the benefit of the industry. So for the industry to see what we have done, and the policymakers also to see what we have done, and so we are approaching. So as for the strategy, because you mentioned that, let's say the strategy as far as the way we approach nuclear power and nuclear technology is staged validation. So whatever we do a risk assessment in stages, and we have specific technology and safety thresholds we need to meet. And once these are met, then we'll go to the following stage. But so that's our strategy. And this is because we want to have a balance between innovation and safety. So that's more or less our strategy.
Very nice. 18 projects is a very good number.
It depends.
Okay, over to Dionysius and Athlos. So Athlos has done a great job in initiating the nuclear energy discussion in Greece. Could you tell us a bit more about what has been the response from the Greek government, the Greek stakeholders, Greek industry, and then what are some questions they have raised maybe, and what are your comments on them?
So we officially formed Athlos Energy September 2024. And I remember at that time I did a Google search in Greek, typing nuclear. And the newest article that I could find was maybe from 2020, saying that we will all die when an accident in Kozloduy, a nuclear power plant in Bulgaria, will happen. So that was the status at that time. Right now, if any of you makes a Google search, you will see that there are multiple weekly articles about nuclear in Greek, even daily. And as you said, yeah, I believe that we contribute a lot on that, also Deon and Antonis Laskaris. When we started, we truly believed that we will find closed doors and people will start saying that we are retarded, crazy, and will start throwing us rotten tomatoes. On the contrary, and that's coming really as a surprise, all the doors were open. Everyone was interested to hear what we are bringing. Of course, we bring our technical background from an established, proven nuclear industry in Switzerland. We have a clear vision, and as you said before, I will rephrase to you, we offer a solution. We offer a solution to the Greek government, but also to the Greek industry, independently if we are talking about maritime, hydrogen, data center, whatever. So to your point, Yanis, both the government, but also the parties of the opposition are open to hear what we are saying. They are open to understand what nuclear means. The industry, independently if we are talking about large companies or small owners, realize clearly that the sustainability goals, the binding sustainability goals that we have in Europe and in Greece by 2050 is impossible to be achieved with the current strategy. That's a fact. And even our Prime Minister yesterday in New York, in one of his talks, he said that we need base load. And this base load cannot come from renewables. That's a fact. So people in Greece are very open, listen what we are bringing. The questions that they are bringing to us are, different compared to their perspective. For example, the public wants to understand if nuclear could decrease the electricity price that they pay, not the day-ahead market price. This is irrelevant. What each one of us pays every day. And this is a very difficult question to answer. At the other point of view, the government and the political parties understand that when we are talking about 10 years range, in order to bring nuclear into Greece, minimum 10 years range, this is beyond their, what we say, chair or duty. And for that reason, they start saying, okay, maybe it can come faster. And this is what we say, yes, if we have the help of the government, we can deploy everything faster. So I think so. It's considerably better, the situation now, than 12 months ago. I'm very confident that nuclear will come into Greece.
Okay, I think this is a good time to bring Aphrodite in the discussion. I will have to improvise. We'll go to Aspasia. But going off the discussions that Athlos had, I mean, as you mentioned, we wrote a very nice ENTHETO publication, 40 pages in Greek about nuclear at sea, the Policy Institute. And you can actually scan the QR code in the entrance if you wish to download it. It's very nice. And I stand behind every line in that report. So could you tell us a bit more about what was the response to the report, some interesting facts, and then maybe some things you hear from stakeholders and Greek government, CIPOD, and so on?
Yes, firstly, I will agree with Dionysis. I think the response has been much more positive than we expected. However, and I will caveat this, and I'm sure you will agree, is that conversations are positive, but the general public is still quite negative. You know, if I think you were showing the numbers recently that 41% of the Greek public is positive, which I think is, down from 60 and 80 in the past. But this number, I think, might be a little bit too optimistic. So if we want the government to make a bold choice, and they can't even do it on their own, you're going to have consensus from all of the different parties, because you're talking about a project that will start in a decade and has a lifetime of 40 years. So you're talking 50 years in the future. So you need political consensus. So you need more education for the general public. And I think, events like this are just a way to start having more of these conversations. So, we all have a lot of more work to do in terms of educating the public. In terms of the response, I think the timing of our publication was very interesting, because I think a few days before we published, the president of IEEA was here, and they were having a discussion about the role of nuclear energy in shipping. Of course, one of the reasons why we published this document was because Greece is, the largest ship-owning nation on the planet, and there is potentially an opportunity to combine the two efforts and find ways in which you can localize value chain, create more knowledge in Greece, not only to provide nuclear energy in ships, which you're talking, again, at least a decade out, but also to use that expertise for Greece inland, be it on floating nuclear power plants or even on land. A lot of the skills overlap, and a lot of the technical knowledge overlaps. So I think we remain optimistic, and I think everyone in this room, they're here because they're optimistic. But I think if we want to see a nuclear power plant in Greece in the next decade or even 15 years, everyone needs to buy in, and you need to be talking to someone in the village that says, yes, I prefer this over 100 different options that currently exist in, green technologies, hydrogen being the one that you most frequently have to refute. So I think we all have a lot of work to do, but there is a lot of hope.
And we do have a question about public perception later with Dionysus, so you'll have a chance to reply. Maybe there is some discussion there or some disagreement. But first we'll go to Aspasia. So the Greek Atomic Energy Commission has the experience of regulating our nuclear safety manners and radiation manners in Greece. Also have the experience of regulating the Greek research reactor in Democritos. Could you tell us a bit more about what preparation is needed and what planning is needed to actually license a commercial nuclear power plant in Greece in, let's say, the next 10, 15 years?
The Greek Atomic Energy Commission, as we call it in Greece, has indeed long experience in transposing to the national regulatory system directives about nuclear safety and radiation protection. As a matter of fact, AI has some experience in the maritime transposition of spent nuclear fuel and the radioactive material from the past operation of the research reactor at the Democritos Center. Greece, as a member of our EU, follows the Euratom treaties and is an active member of the European Nuclear Regulators Group. This is called ENSREG, and is aligned with the European and the International Atomic Energy Agency directives, safety principles on nuclear safety and radiation protection, spent fuel and radioactive waste management. At the national level, with a presidential decree in 2012, the Euratom Directive on nuclear safety was transposed to our national legislation, and a ministerial decision followed that specified the licensing requirements and the regulatory control of research reactors. This ministerial decision now applies to the decommissioning of GR1 research reactor at the Democritus Center. Although nuclear safety is covered at high level in our country, there are some challenging limitations with regards to certain and specified applications. It applies only to land-based and research reactors. It cannot be applied to any other application. As you can understand, the general requirements that apply to a research reactor cannot be applied to any other power plant. Their scope is different, their operational characteristics are different, the output power is different, the safety requirements are different, and of course they demand different waste management and the spent fuel procedures. However, the generic licensing steps that apply to a research reactor may, of course, apply to a power plant. That is, feasibility studies, environmental studies, siting studies, license to file, to construct, to operate, and then decommissioning, of course, can apply to any power plant. New legislation has to be created, and the creation of new legislation or to update existing legislation takes time and demands specialized manpower. AI has experience in dealing with novel challenges. An example may be the regulation of cyclotrons. A few years ago, these applications did not exist in the country, and now there are 4 operating units, licensed and operating units in the country. Regulative innovative technologies, particularly in the maritime sector and FNPPs, is an open issue internationally. And there is scarcity of specialized nuclear experts internationally, particularly in the case of Greece, which is practically a non-nuclear country. AI offers scholarships to young scientists in order to build the national expertise in nuclear power and strengthen our capabilities. And to conclude, learning about the novel technologies, developing the necessary skills to build competence, increasing the manpower, the specialized manpower in the regulatory body, both by attracting new talent and by mobilizing the existing experts to embark on the nuclear regulatory program, are the key enablers of a robust and resilient national nuclear regulatory ecosystem, and AI is actively working in this direction. Thank you.
Yeah, I think it was one of the reasons we are starting these discussions so early is because there's a lot of work required on the licensing and regulatory framework. But I think, as was mentioned previously, there's a lot of Greek talent that's not necessarily in Greece right now that works in nuclear industry, and
That's right.
some of them in this room, but they will be eager to come back into the country and work in different positions if there is an actual program.
It's a great opportunity to mobilize all the
Exactly. Exactly. And I will say also the scholarships that they give out, they are 25,000 euros per year, and they go very significant amount, and they go to non-Greek students that study outside of Greece. And they've been to very good students so far. I know them both, they are excellent. So it's an extremely good initiative, and I think it motivates a lot of students, Greek students. So we'll go to Arla. So we mentioned the siting study. So actually, a type of high-level siting study is the first step to our PESTLE project we are doing with ABS and Athlos. So we've looked at all the potential sites in Greece, and we've defined some criteria so we can perform an analysis to identify what are the best candidates. And Arla, as the leading analyst on this study, could you tell us a bit more about the criteria we defined and some of the outcomes?
Certainly. So essentially, we have a JDP, so a joint development project in collaboration with ABS and Athlos Energy. And the idea is to evaluate the potential deployment of floating nuclear power plants, or FNPPs, at selected sites in the Mediterranean. So we have tried to build a methodology which in the future might be applied to other countries as well. But at this point, it's located in the Mediterranean and specifically in particular Greek sites. So at the moment, we have considered around 20 sites in total, and we have built this methodology, which in the end is meant to be quite comprehensive in the sense of taking into account all the potential compatibilities of our own product, but in the spectrum of technological, legal, social, political, and in the end, obviously, the commercial use case or economical. So the methodology itself is based on 17 criteria, which are based and taking into account relevant literature, also IEEA guidance, and further on our own engineering expertise in terms of understanding whether the technological parameters that we bring forth are adaptable to the site that we are considering. So we can say that the siting study itself takes into account, for example, at particular sites, the site demand. So we have a criterion that measures the current, but also the projected energy consumption at each site, and also the addressable gap that the FNPP could provide to the market. We take into account the utilization opportunities. For example, if a site might have simultaneous kind of opportunities, such as if a site might be treated as more favorable, if at the same time there might be an oil processing facility nearby, or we might have potential data centers that have been projected for the future. We might have desalination units. So if we have an FNPP that is providing energy simultaneously to all of these sites, it classifies the site as being more favorable for the future. We also take into account site grid capacity, which means, for example, if we need to consider a site that has existing infrastructure, or if we need to provide more investment in the future. So if the existing infrastructure is adaptable, that's better for us in the sense that we take into account the transmission, the high voltage transmission link, and also the spare power headroom. Further on, we consider things that are a bit more technical, but also more site-specific, such as in Greece. We all know that Greece is an earthquake-prone territory, so we need to consider seismic activity for certain sites. We need to consider wind strength for certain sites as well. Not that our FNPPs cannot manage wind, they do, but we need to consider essentially the flexibility of our design. So, for example, if we have an area such as Santorini, which is exposed to prevalent winds, we need to take into account what further adjustments might be. We also have considered minimal depth. So this is a technical criterion of our FNPP, breakwater and sheltering. For example, we know that some gulfs might be much more exposed. Some others might need more investment for breakwater. Further on, we have considered, as we know, Greece has tourism as one of the key economic activities. So we need to consider touristic surges. If some places, and in this respect, we need to consider touristic surges in the sense that, for example, what the public perception might be, but also how Greece itself might treat it as if it's going to affect the tourism or not later. Population proximity is a very important criterion. In our case, we have considered those places that have more dense areas in the sense of emergency preparedness, rather than something more specific. And then obviously we need to consider those sites that have emergency infrastructure already in place, such as fire stations or hospitals, and obviously hospitals with big enough capacities. So all of these criteria, which at some point might seem trivial or very small, have been taken into account into this very first and comprehensive study in the beginning. But obviously later on, it will become much more in-depth and also much more analysis to be required in collaboration with both ABS and Athlos in the PESEL study. And everything then will be compiled and condensed all together into a white paper that we are going to publish in the media, and it will be available to all of you later on.
Good. Excellent. Okay. So I'd like to turn it to some audience questions, and then we do have a second round of questions, but because we're in overtime. Yes, someone here.
Hi. What's the operation or the expected operation plant site?
Yes. So the question was about the commissioning of FNPP. So I'll try and answer the first part, and then I'll pass it to you, Aspasia, to also answer. So the decommissioning plan will be developed when we have an actual plan design that's going through a licensing process. Right. So there is no specific plan that we have in writing right now. The general idea is that the floating power plant will be towed to the place of operation. It will operate for its life cycle, and then for decommissioning, it will be towed away. It will be taken to a nuclear licensed shipyard, not necessarily in Greece, right? This can be elsewhere. And in that shipyard, all of the decommissioning steps would happen. So we'll have refueling, we'll have all of the steps that you need to do, right? So FNPPs do offer this very nice opportunity that actually we can skip the decommissioning process in Greece, and the owner operator of the barge can do that outside of Greece in their own shipyard. So that's a high level answer. I don't know, Aspasia, if you want to add to that.
Okay. At the moment, what I can add is this: that in order for any nuclear installation to get licensed to operate, has to have an approved decommissioning plan, and that the decommissioning procedure and all the waste, the spent fuel that are produced by this operation are responsibility of the owner or the operator of the facility to manage. This is what I can answer right now.
So just to say that as a classification side should also look into the decommissioning plans on that, because if in the future we have nuclear powered vessels, let alone the FNPPs, we have to consider the amount of decommissioning over the lifetime of the vessel, and so far the numbers are a little bit interesting because there have been 70 in the last 70 years, there have been 200 decommissionings of, let's say, nuclear reactors. But if we consider we have like 60,000 vessels above 500 tons worldwide, of which 20,000 are the big ones. So if the big ones, which are more suitable, say, for nuclear power propulsion, were to be decommissioned, then we would need to have more proper infrastructure to do that. Otherwise, it will not be possible to do it. If we do 200 decommissionings in 70 years, then the math say that if we have 20,000 vessels, then we'll have 800 decommissionings per year. So instead of such a small number we have been so far. So we have to look into the infrastructure that, and classification side should also look into that, I think.
Very interesting. Back to the discussion on the public perception, because I think we left an open subject. So question for Dionysus, and I'd like to discuss with Aphrodite as well. What is the current public perception of Greece? We know that basically following the Chernobyl accident, the connotation for nuclear and for Pyrrhinica says is generally negative, right? The first reaction. Could you tell us a bit more about that, and then we can discuss?
Yeah, not only Chernobyl, but also Fukushima. And for those working in the nuclear industry, they can understand what was the impact. Here I have to say that we, the nuclear industry, made a huge mistake all these years. We never communicate with very easy words, as you did today in your keynote speech, what is nuclear. We have to go back to what is the atom in order for the people to understand. Because of course it's not easy. I mean, you should not have a PhD in nuclear physics in order to understand how these machines work. Pretty much it's an easy thing, right? It's a pot, but instead of water, you have nuclear fuel, uranium. This is all. So the public perception is a very good point. I mean, people are afraid because they don't know. The Greek Commission in 2018, I think so, made a survey which resulted that 75% of the Greek population is against nuclear. And then you're right, in the European barometer, made several studies in 2021 and 2024, and they said that in Greece, there is something like 40% pro-nuclear. Also for me and Stathis, that was a little bit fishy. I mean, we didn't really believe that this is so high, the number. Of course, at the same time, people were saying to us, yeah, I mean, if Greece is going to build a nuclear power plant, it will be like 95% against. So for us, it was very important to understand what the Greeks believe. Therefore, in this summer, in August, and this is exclusivity, but I will not reveal all the information because you will see it very soon in the newspapers. We performed for the first time a dedicated survey in nuclear in Greece with 30 questions, demographic statistics in order to understand not only if it is yes or no, but also, people from different ages, different areas of the country, what it is, what is their opinion. The number is not 40. It's a little bit less for pro-nuclear, but the number for against nuclear is significantly lower than 75%. I will not reveal this number, but I will reveal another number. We made 2 more questions, which is very relevant for you and for our projects. We asked the Greek people, what do they believe? Are they against or pro for a nuclear installation, either in a floating reactor or on a vessel? And surprisingly, 50% were pro. So more people in Greece are in favor of a nuclear installation in sea than in land, which is very interesting. And this is just the start. I mean, pretty much we have done nothing up to now. We are starting the public engagement. So if we do our job correctly, I'm pretty sure that these numbers will start increasing significantly. So, but you will see more information in a few days in the news.
It's great news. It's the first time I hear it. So it's very nice to be revealed in this conference. I think it's a better time. Do you have a question? Let me just get your microphone first.
Short comment, really. Dionysis and all. I believe in Greece and maybe in many more countries, actually the public has no clue of the amazing features of the new reactors. They know nothing about passive safety. They just know what has happened in the past. So their answers are based on that, not on what is actually proposed.
Yeah.
So I consider that if our governments, if Athlos, everybody works more to educate that what we're talking about, I would say countries like from Austria and coming Eastern, which are not connected really, like Germany with buying and selling electricity, we are desperate to new ways to produce cheap electricity. And I would say the public will first engage. Of course, if somebody managed to answer the difficult question you said, Dionysi, will it be cheap after all to produce, the electricity with a new safe ways, actually.
If I may simply add, we made one more question asking the people to comment if the different types of electricity production in, like coal, wind, nuclear, whatever, produce minimum or a lot of CO2 emissions. And surprisingly, 60% of the Greeks said that nuclear produces a lot of CO2. 60%. And this, I'm not laughing. I mean, it is a reality, and we have to take it very seriously.
Okay. Thanks.
Can I just add to that, maybe a small comment? It is not the new nuclear that is safe. Right? So existing nuclear is very safe, and I showed it with data. Right? So, and this is sort of a marketing thing. Advanced reactors marketers, they market their technology as more safe, which it is safer. But existing nuclear is already one of the safest forms of electricity production we have. So it's also a good point. Any comments from the panel on this discussion? Okay.
May I add one thing on pricing? And I think this is extremely important. In a lot of conversations, you hear nuclear is not cheaper than solar, nuclear is not cheaper than wind. That's not a fair comparison. We need to shift away from that model, and it needs to be solar plus whatever storage you have, or solar plus dirty backup, which should have a price of carbon, right? So I think this is part of the education in terms of once we have a price that we can defend, there's studies around what that number will be, but eventually we'll have more data. But that price needs to be compared to a system level 24-hour cost.
Yes. Okay, last question.
Is it working? I think what you've done is going the right way. Otherwise, we will get bogged down in public sentiment. The politicians will come into it, and nothing will happen quickly. Thank you.
If I can just add, my name is Philip Nelson. Although my name is quite close to research, if Henry Ford had asked people what they wanted, they would have replied, faster horses. So maybe keep that in mind.
Okay, with that very nice quote, they're signaling me to end the panel, then finally have some nice cocktails. So, Charlotte, take it away.